Gonna do a little duct sizing tutorial here. This is a Lennox duct calculator. It's kind of the one I've always used. Here's another one. Bottom line is, when you're doing a furnace install, you want to make sure your duct work is sized accordingly to the airflow you need for your ducts. Well, furnace sizing obviously first, and then look at the airflow charts for your furnace and your air conditioning. 90% furnaces are typically going to want to move more airflow than back in the day in the 80s, when every house didn't get air conditioning, we'd size for air conditioning. But now we've got usually all 90% furnaces, so those typically need more airflow than the air conditioner. So our recommended residential setting is 0.1. We got our round ducts here. As you can see, if we put that on 6, which is a typical branch run in a residential scenario, a 6-inch pipe is going to move 120 CFM up here at 0.1 static. And a 7-inch is about 150. And an 8-inch, typically your returns should be all 7-inch, because we usually are just cutting it close on having enough return in any given residential setting. So you're getting 50 more CFM by running your returns in 7-inch. An 8-inch will move twice the air. We're moving 240 approximately on an 8-inch pipe. And a 10-inch will move 2 8-inch. So you could feed 2 8-inch pipes with a 10, or 4 6s with a 10, because we got about 440 there. So that's kind of how that works. 12-inch is like 750, I think. Yeah, 750, 700, somewhere in there. Sometimes we'll do a shoot to the attic and come back down to all the supplies on the second floor if you got a zone system or whatever. That's pretty much the biggest pipe you're going to see in a residential setting is 12-inch. Nobody wants 12-inch duct running across the ceiling in their furnace room, but it happens. I got a 12-inch bypass damper down in my furnace room. Anyway, looking at rectangular, the typical rule of thumb would be, okay, the smallest rectangular we'd use is about an 8x8. And you can see that's about 300 CFM, which would be 3 6-inch pipes. The rule of thumb is 2 inches for each 6-inch pipe, and then add 2 inches at the end. So if we had 3 6s on an 8x8, well, that'd be 3 times 2 is 6, plus 2 gives you your 8x8 duct that'll safely carry 300 CFM here at 0.1 static pressure. So that's kind of the scenario with the duct calculator. Now if we take and look at, let's just say the furnace is down here. That's top view of the furnace. And we've got a supply here, here, and here. So we've got 6-inch, 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 and then maybe another 3 6s over here. And a couple on the end down here somewhere usually, but let's just use this for this situation. So, and the other thing is, we usually end up with way more 6-inch runs than we need. So if you got like a small bathroom, right here, it really doesn't need the full 120. Maybe you figure 80 CFM for the small bathroom or something, or 70. Back in the day, we used to run 5-inch pipes to those small rooms that were 70 CFM. But in today's world with labor costs and not having all the stuff around, piles of different size pipes, let's just keep it simple. And okay, let's just, for the sake of this, figure 1, 2, 3, 4, 5. Let's say we got 570 CFM between those 6 right there. And then let's just make it interesting. So 570, and then we got another, let's just say we got another 200 coming off the end down here. So there's a 6-inch and another 6-inch. Okay, you can see all that. So if we add all that up, we're going to have 570 plus these two, so about 770 CFM total. And if we look at our duct calculator and go 770 CFM at 0.1 static, you're somewhere in there. And then come down here, and your typical duct is 8 or 10 inches deep. So that's about a 16 by 8 duct. So we're going to come off the furnace here with a 16 by 8 duct. And, to make it flow good, and you don't want to run 16 by 8 all the way down here. So we take this 6-inch off here and a 6-inch there. And rule of thumb would tell us we could reduce that by 4 inches. So if we take 200 CFM off of this, for those two, we're down to 570 now. Let's see what 570 is. $570. So now we're at 13 by 8. So we don't have a 13 by 8, so we're probably going to go, what we could do is go out one more, or we could reduce. That's kind of overkill, reducing a 14 by 8 right there, but let's just do it. So we'll go down to 14 by 8 and say we will go, let's just go and pick up the rest of these now. We'll go the rest of the way. Or you could reduce again right here. Right here, after you take off these two, you could put another reducer and go down to 12 by 8. So you kind of see what I'm getting at. Say we did run the 14 by 8 all the way out. We put an end cap here. What we could do, just for the sake of learning, we've got 2 6s down here, and we know that an 8-inch is 240 and a 6 is about 100 or 120. So we could take an 8-inch off the end cap. That's not a good practice. Maybe we take an 8 off the side, and we come down here and we put a cap on it. And we could put a 90-degree saddle off the side of that 8-inch round that we just carried off this, what do we say that was, 14 by 8. And we could saddle off the 8-inch down here, or you could reduce down to 8 by 8, which is bigger than we need. The 8-inch is almost going to give you better flow if you or you could go to an 8 by 8, because they really don't make anything smaller than that. And your 7-inch takeoffs come off the top. Typically, you're always going to want to take the takeoffs off the top if you can, because the air, when it's traveling through the ducts, is always trying to hug the top of the duct, which is why we put our takeoffs on the top, which is why if we went to an 8 by 8 here, the takeoffs are 7. The 6-inch takeoffs go from 7-inch round to 6-inch. when you cut them in the top. So that's kind of the scenario there. And then the return, same way, except you're running, you got far less returns in the house. You got 3 bedrooms, living room, and then maybe you got your basement with a bedroom and a family room. So you would put a 7-inch. Typically the basements don't get finished right away, and there's enough return, because you have to put enough return in the house whether or not the basement's finished or not. So you're getting that from somewhere, or maybe you're just drawing a return. You got your return over here, and the duct that it's cut into running down the house. A lot of these have truss joists now, and then they're flexing everything off of whatever you got there. But say we had a 1200 CFM need for our minimum airflow. So if we look at 1200, or just divide 1200 by 150, what does that come out to? 1200, 150 times 7, that's about 1050. So 8 returns would be 1200. So if we needed, that's 7-inch now. 8 7-inch returns to get our 1200 CFM. So you just need to pipe your 7-inch to your, each bedroom requires a return. Say you run into a spot where you can't run ductwork, then you're going to have to go to like a bigger grill. So you can only get 300 CFM, 2 or 3, say 450, and then you need 800 CFM from, like, you could just create a huge grill somewhere, like whatever size, like 800 right there would be a 22 by 6 or a 16 by 8 or 12 by 10. You could do any of those scenarios to make up the difference of not having room to run ducts to all the places you would really like them. So that's kind of how duct sizing works right there. Hopefully you learned something.